So guys and girls, this week we will cover chapter real time system design. Okay, so we have covered software process model, requirement engineering, chapter 4 and 5, and then design concept we already learned, UI design also, architectural design also, and then today we will learn about real-time system. Okay, so we already learned about software testing also. Then later we will learn about, so we have left 3 chapters. Okay, so software evolution, AOSE, and CBSE. So today we will cover this lah. So if we finish this early, then we can proceed to the software evolution. Yeah, so I hope you all already can see the mind map of the connection of each of the chapter that we have learned previously. Okay, so today we will proceed to the real system. I will just directly proceed lah. Um, but before that, oh yeah, yes, I'm presenting. Yeah. Okay, just now what I have showed actually that you all didn't see is this one, the mind map. Okay, so this is the SDLC stages. Okay, so previously we have learned chapter 2, software process model, requirement engineering in chapter 4 and 5. And then after that, in the design, actually there are a lot of chapter that only talking about the design. So far we already covered design concept, chapter 9, UI design, chapter 8, architectural design, chapter 6, and then today we will cover real-time system design. And we have already covered the software testing, where we have learned all of the test case and the test plan. And then soon we will learn about software evolution. And then lastly, we will learn these two, AOSE and CBSE. Okay, so actually what we will learn, all of our chapter that we have learned since the early semester is actually all the the things that you all will need to know in order to develop a software. Okay, so this is the STLC is actually we call it as a software engineering lah. So this is the software engineering stages. Okay, so that's why, and then we already covered the project management also lah. So this project management is the process and the knowledge that all of the software engineer need to know in order to manage from the starting of the software development until the end of the software development. Okay, so we proceed to the real system design. Actually kan guys, do you all agree if our third presentation will need you all just to submit a video? I, I keep thinking because um, actually we I think later I will just get the average from your presentation 1, 2 until 3. Okay, so do you all agree? Because if actually this chapter, this course previously, initially, if you all see our assignment, the student needs to submit video, right? From KLCC, uh, they just said that For the presentation, student can submit record. Okay, but and then for the presentation, is this it? I think yeah. Wait, okay, so here, yes. Okay, so I think it's better if we do the presentation 3. You all do the video and then submit the video, because we have already do the presentation for part 1 and part 2, right? So I think it is quite enough for me to check your ability to answer questions spontaneously from me. Because I can see that because we have presentation, we have used the practical time until some of the, because I am afraid that we cannot cover our tutorial, because our presentation will use our our tutorial time, right? So yeah, I think that's enough lah for part 1 and part 2. We already have our the live presentation, and then for the part 3 I will need you all to just submit the video. And then this this Thursday we will discuss about the tutorial, and then maybe I can add, we can do some of the we can proceed to the chapter software evolution, the chapter 11 just now, right? Okay, can okay, so yeah. We don't have ka? Well, I think I have asked in our WhatsApp group, and then I can see that there's all of the student agree. Later I check first. Maybe I have referring to the wrong group. Mm, yes. Um, I can say that the video due date will be on Friday this week. Okay, Friday this week, 5 p.m. Let's, okay, let me check first. Okay, here. Alan Noel, you forgot me. You remember here I have asked continue class on this Thursday on 16th September. Yeah, of course. Your video memang need to see first lah. Okay, so previously, actually the CC only needs you all to present, just submit video lah based on the assignment. But when I see the rubrics, they are Q&A, and then you're confident when you are answering questions. So by just submitting video, I cannot assess that criteria. So that's why I require you all to do the live presentations lah. When we ask the CC for this course in KL lah. So the reason why they need to the student to do the video, because they have a lot of student, so they don't have enough time to do one by one group, one by one presentations lah. So that's why they need the video. But since in our case we don't have a lot of students, so I prefer to do the live presentation lah, so that I can assess your confidence, how you answer the questions spontaneously. Okay, so that's why. But since I think even the planning also because they assume us all will do the video, so they don't the CC didn't allocate time for the presentation, live presentation, so we use a lot of time out of our tutorial. So I think it is enough lah, two presentation using live presentation and then one last presentation using video lah. Okay, so need to see face. So Google Meet, what is OBS? I thought that what is specifically presentation only. Oh, okay. So it is for class lah, Noel. Okay, ngam lah. Oh, so Russell, you also thought the same like what Noel said? Yeah. Or you thought so because of what I said just now lah? Oh, Noel. So previously, I think yes, because we do the presentation lah on this Thursday. But when I think that we will use a lot of time, so we don't have enough time for tutorial. So we continue the class lah for the tutorial and continue to the chapter 11 lah, kan kah? Okay, so yeah, so everyone, if you have problem with that, nanti you all can can PM me. Okay, so we cannot waste any more time, so we proceed lah. Okay, so this week we will cover the real-time system design. So in the design, like I said just now, if you see the mind map, in the design stage only, we have learned 4 slides or topic: the UI design, the architectural design, and then the real time. So this is the 4th topic or chapter, just under design stages in software development lifecycle. So the objective for this chapter is to introduce to you all. There are some terms that is related to the real-time system, and then to describe the design process for the real-time system. Okay, so what is actually the real-time system? So before we proceed, I want you to know what is your imagination or what do you understand about real-time system. May I know, may I get feedback from any 2 of you or 3? What do you think about the real-time system? How it is different with the current or normal system or common software system? Okay, so the example of the real-time system is self-drive car. Yes. So this is the example. So what is other than that? Other student? COVID live report. COVID live report. Okay. Yes, correct. The real-time system is like GPS. Yes, that is also one of the example. All of what you answer here, kan? It is all actually the example of the system. Traffic control, yes. Live election result. Ya, boleh. Traffic control. Okay, so all whatever that you have answered now is all actually the example. So the real-time system, actually the definition of it is the system that generates some result or action in response to the external event. Okay, in response to the external event in a specified time. Okay, so meaning to say that system it will give some result. There will be a result that will be produced based on some external event or trigger or stimulus. Okay, but it will give the result in a specified time. So all of the system that you have said here is fulfilling the example of real-time system lah, because it is all will produce some result or action based on some trigger or event from the external in the specified time. Okay, so for example, self-drive cars. So there are some, maybe there are the stimulus for that self-drive car is the, I am not sure lah, but of course lah, that self-drive system, it can automatically drive itself, and then it will get some information or sensor. It surely it will have some sensor that will detect the maybe the speed or the jarak from the car to another physical entity, so that it can avoid that entity, right? So there will be some sensor, and that sensor will give the trigger to the system, and then that system will give some result or feedback or action in the specified time. Okay, so same lah with all of the GPS, COVID life report. So COVID life report maybe it will be triggered by the uh, routinely updated data. Okay, so for example, for Sabah, usually there will be only stop calculating all of the statistic up until 12 p.m. of that day. And then after that, the data will be bring to the tomorrow punya data. Okay, so that is what is the real-time system lah. Okay, so it will best, like I said just now, I will not repeat again. Okay, so the real-time system, we have two types. Okay, so soft real-time system, where uh, the soft real-time system, it is the real-time system where the operation of that system will be degraded. Degraded meaning dikasih turun sejak sikit. If the result are not produced according to the specified timing requirement. Okay, so for example, if that system supposed to get some input or trigger in that specified time, but it didn't get that input, then the operation of that system only degraded. It will not stop or what. It will only degrade it, or it will produce some output, but with a degraded level or status. Okay, so the another type of real-time system is hard real system. Okay, so hard real system where it is the time system where its operation will be getting incorrect or error. It will cause the incorrect behavior, or it will directly make the system got error or fatal error if the result is not produced according to the timing specification, meaning it will be terus kena stop. For example, if it didn't get the sensor or the information at the specified time, then the system terus produce error. Okay, so the soft real-time system, it is a little bit, it is not really strict compared to the hard real system. Okay, so the example of the soft real system just now is, for example, the interactive video game. Okay, so meaning if you didn't get some ranking, or you didn't get the marks during a few minutes, it will not kasi log out you terus lah. It still can wait maybe some of there are some action that still can be offered by the system, but maybe kurang lah your life. Okay, so your system or your game tidak kena terminated, tidak is not terminated terus. Okay, so that is the example of soft real time system. But for the real time system, the example is like the aircraft traffic. Okay, the aircraft traffic control, like what Shak have, but you are maybe referring to the road lah, right? But here is the aircraft traffic control, meaning it cannot tolerate any error because it is a very strict. It must get the stimulus or the stimulus or trigger in the specified time. If not, dia memang error terus. And then another example, if the life support system, like the software that is used in medical or in clinic to check the heartbeat, okay, the heartbeat lah. Okay, so these are the comparison between hard real time system and soft real time system. So for the hard real time task or system, the system must meet its deadline, meaning here must compulsory. For the soft real-time system, it has an associated deadline that is desirable but not mandatory. Okay, so remember just now the example is the interactive video game. And then after that, if the system didn't meet its deadline, it will cause the unacceptable damage or a fatal error to the system. Okay, so whereas the soft real-time system, it still makes sense to schedule and complete the task even if it has passed its deadline. Okay, so like I said just now here lah, the example here. Okay, so we will learn about the stimuli of the real-time system. The stimuli is the external event or trigger that that will trigger the action of the real-time system. Okay, so this stimuli will cause the system will change its state. Okay, so this stimuli will cause the real-time system change its state. Okay, so when the real-time system change its state, so it can use state machine modeling. Okay, so this is the example of how the state machine model for microwave oven. Okay, so you all will learn about the state machine model. I think maybe in your next semester lah. Okay, so but this is the example of diagram or the model for state machine model for the microwave oven. Okay, so in the oven there are two steps, either idle or it has power on it lah. Okay, so microwave oven, right? Okay, so first it will be idle, but when the full power triggered to the microwave, it will trigger the timer to be set. Okay, so in this case, the microwave oven have two types of stimuli, which is the full power on or the half power on. Okay, so but both stimuli or the event or the external event will cause the timer to be set. Okay, so once the timer set, the door of the microwave oven will be closed. And then after that, the operation will be enabled, meaning kasih panas sudah lah. And then there are another stimuli here, the event will cause the operation of the microwave will be disabled. Where? When the door open. Okay, so maybe somebody forgot to pause the timer, and then it will make the operation disabled. The pause the timer and then directly open the door, then it will make the operation disabled. So when the operations already enabled, so it will start the time operation. So when the time out, then cooking will be complete. And then the microwave will going back to its first step, which is idle. Okay, so similar in here, there are when the door will be open during the time memasak. Okay, so it will also make the operation will be disabled. Okay, so the stimuli here first is power on or full power on or half power on, and then it will, this is the response. Okay, so after that, another stimuli here is the door open. The door open. So when the door open, it will make the operation disabled. Okay, so when the door close, it will make the operation enabled. So okay, so that is the process of the step machine model for a microwave oven lah. So this is actually the example of step machine diagram. Okay, so in the software requirement design, if not mistaken, there are a topic about step machines, but I cannot really remember lah. Okay, but maybe I am not sure if you all will learn about software requirement and design in the future. But for the SF, they already learn software requirement design lah. Okay, so the real time system will have the stimulus and it also will have the response. Okay, so if when there are any stimulus or trigger, the system will must respond to that trigger. Okay, so there are two classes of the trigger or the stimulus. So when I said the trigger, it is the stimulus lah, something or event or external event that will trigger the system to give response. Okay, so there are two types of stimulus, which is the periodic stimulus and aperiodic stimulus. Okay, so the periodic stimulus is, this stimulus will occur at predictable time intervals. Okay, so for this periodic stimulus, it will be triggered by some time interval. Okay, so for example, the system will examine a sensor for every 50 minutes and take action or response depending on the stimulus. Okay, so for example, so this one, for this stimulus, it will, the system that will check the stimulus in the interval time. So it will be depends on the configuration lah. Okay, so for example, for example, the COVID life report, right? Okay, so the COVID life reports, usually they will only take the data up until 12 p.m. of that day. Okay, so if tonight the statistic obtained by the Kementerian KPM. Okay, so that data is actually up until 12 p.m. today. 12.1 p.m. up until the berita tengah malam. Start from the 12.1 p.m. The statistic will be brought to tomorrow punya statistic. Okay, so the interval for this, for the COVID life report, is maybe 24 hours, but it will be start from 12 p.m. until 11 it will be start from 12.1 p.m. up until 11.59 a.m. on the 24 hours lah. Okay, so that is the example of periodic stimulus. Okay, so the system will check periodically. Okay, so a periodic stimulus, it is not based on any time interval, but it will be occur irregularly. Okay, so only when they are interrupt, the system will give response. Okay, so this periodic stimulus, it will be based on the interrupt from the outside event. For example, if you are copying some video, the video will take a little bit time lah, right? Using your laptop. And then while you are copying, you are doing something. You are maybe editing a slide PowerPoint. And then after that video is finished, completed, kena copy, then there will be tiba-tiba a dialogue message that telling that okay, the system already the copying already finished. So they are the interrupt there. The process of you editing your PowerPoint interrupted by the completeness of the copy video. Okay, so that is the example of the periodic stimulus. So far so good?
Okay.
Okay, thank you, Farah. Okay, so that is because if you see in our slide, it didn't explain more lah. Okay, so you all can remember my explanation lah. Okay, so these are the stages of the real-time system design. Okay, so when you need to design a real-time design, the first thing that you will need to design or identify is the stimulus of your system, the trigger. What is the external event that will trigger your system? Okay, so after that, you will need to determine the time constraint. Okay, so for how many times interval that the system will need to be stimulated. Okay, so after that, what are the concurrent processes that may be happening during the in your real-time system? Okay, so after that, after you have configured what are all of the processes that will be need to run together in the same time, you will need to come out with algorithm for each of the processes. Okay, the algorithm is like your pseudocode lah, what need to be happen, what you will need to code later. Okay, so after that, the scheduling system, you will need, after you have done the algorithm, then you need to schedule lah. Either the process is concurrent or it is one after another. Okay, so after that, we will need to choose the real-time operating system. Okay, so the real-time system will need a OS, its own OS. Okay, so the OS we call as real-time operating system lah, RTO. OS. So we will learn about that later in the next slide. Okay, so this is the example for the intruder alarm system. Okay, so first, during when you are imagine you are designing intruder alarm system. Okay, so this system will can give response if there are any intruder that coming to your house ka, apakah. Okay, so first, we need to identify the stimuli. Okay, so in this stage, we need to identify the stimuli, and then its associated response. Okay, so we need to identify when the stimuli is triggered, what are the response from the system. Okay, so for example, if the uh, for the intruder alarm system, so maybe the alarm will be triggered lah, dia berbunyi kuat lah. Okay, so the response first, the automatically the automatic response from the system is check which room number that has the intruder, or can maybe automatically call police, or initiate voice synthesizer, or switch on audible alarm, or switch on the light. Okay, so these are maybe the possible responses that you can give the response to this stimuli. Okay, so here is the things that you will need to consider. You need to consider during the stimulus punya stage. After that, the timing constraint. So for the stimuli to get the response from the system, you need to identify what are the timing needed. How many seconds, how many minutes will be needed for the response to respond after the system detected or censored the intruder. Okay, so after that, we need to identify the concurrent processes. Okay, so for example, the concurrent processes in the intruder alarm system is the process of Windows sensor process, door sensor process, and motion sensor process. Okay, so all of these sensors are needed in order to sense if there are any intruder to your house or to your building. And so they will need to be run together in the same time in order to detect the intruder. So that is the example of concurrent processes in the intruder alarm system. Okay, so these all are concurrent processes. Okay, so these all processes will be needed to detect the intruder. So after that, we create algorithm for each of the processes just now. So for each stimulus and response, it is not for the processes lah. For each of the stimulus and the response, okay, so we need to carry out or design the algorithm to we do the flowchart ka or pseudocode ka to how to code each of the process. Okay, when the stimuli have need to give or need to trigger the response from the system. Okay, so yeah, here for the stimuli to get response, we already get the timing from the previous stages, and then we will need the computational algorithm in order to carry out this response. Okay, after that, scheduling system. Okay, so this set of stimuli, if previously it is the algorithm for each of the stimuli to respond to a response. So now in the scheduling stage, we will need to schedule a set of stimuli and responses, meaning there are more than one stimuli and responses. Okay, with together with the timing and then together with the computation algorithm, so that all of that set plus the scheduling system, meaning we in this stage we determine who is first, who is next. Okay. So after that, we need to design or pick or choose the RTOS, real-time OS for our system. Okay, so this OS will be responsible to manage processes and resources allocation such as the processor and memory in real-time system. Okay, so it is like the common operating system lah, but it is designed for practically or it is designed memang for the real-time system. So usually RTOS will be used in it is embedded OS, like whatever it is, like just a small the common OS is what we have in our laptop or PC. But for the some machine that we for the system that we embed to devices, it is usually using RTOS, real-time operating system, like what we have put in the car just now, self-drive car, and then the washing machine. Okay, so these are the summary lah. There are 6 stages in order to design the real-time system. Okay, so we proceed to the real-time system design. So real-time system, still, I mean, we are still in the real-time system design lah. This one is stages, and then this is more on the real-time system design. So real-time system must respond to stimulus at different time. So its architecture must therefore be organized so that the control is transferred to the appropriate handler for the stimulus as soon as it is received. Okay, so so this is the real-time system memang need its own architecture. So because its own architecture is organized to control the stimulus to its response. Okay, so to assign the stimulus to its response, so it will need appropriate handler for it. Okay, so these are the about the RTOS, the operating system for the real time. Okay, so as I mentioned previously, its responsible is to manage process and resource allocation. Okay, so it also need to be able to detect stimulus, not to detect lah, to manage process of stimulus, and then it also have the ability to stop the process, and then it also have the ability to allocate memory and resources. Okay, so so this allocate memory and resources will be based on the stimuli lah, or the stimulus. Okay, so this is more on the real-time OS, RTOS. So it is actually the analogous to an operating system in a general purpose computer. So general operating system in a general purpose computer is whatever operating system that we are using in our laptop or in our computer lah, personal computer. So it also manage processes and resource allocation, like whatever that I have talked previously in the previous slide. So the example, it can start and stop appropriate processes so that stimuli can be handled, and then allocates memory and processor resources to the stimuli and then give the appropriate response lah. Okay, so this is actually the 5 component of the RTOS, but I will need you all to find out the task of each of these component. Okay, so in our tutorial letter, there are questions at. Okay, so this is the questions at. So you all will need to identify, please use Google to search about each of the tasks for this component lah. Okay, so that you all do some reading lah. I know you all are also memang doing the reading, but this is another reading for you. Okay, so if you see just now, there are 5 component for RTOS. Okay, so this is the example of how each of the component inside the RTOS are working together. Okay, wait Okay, so that the azan also just now, I think it is also real-time example of sorry, it is also the example of system, a real-time system, because it is triggered by some because it is triggered by the time. Okay, so the trigger or the stimulus for it is the timing, the time given by JAKIM. JAKIM is Jabatan Agama. I forgot the full name of JAKIM lah, but it is the Malaysian punya association that manage all the Muslim punya apalah. Okay, so that is actually the example of periodic stimulus using timing. There are some time interval that will trigger the azan to be to ada dia punya sound. Okay. Okay, so this is how each of the component in the RTOS will working together. Okay, so first the scheduler lah. The scheduler actually will receive some information from real-time clock, and then it will also maybe will get the stimuli from interrupt handler. Okay, so beside that, it also will need the scheduling information. So the green one here is the component of the RTOS. So here the yellow one is the information that it will need. Okay, so for the scheduler to be able to schedule, it will need the real-time clock punya input, and then the interrupt handler input, and then also the scheduling information. Okay, so after that, the scheduler will output or produce the awaiting resources. It will process the awaiting resources. Okay, so it will produce what are the resources that are still waiting. That should be inputted in a buffer to await for them to be served by the manager. Okay, so after that, this resource manager will need the input from the requirement for each of the resources here. So when they see the list of the awaiting processor resources, this resource manager will check the process resources requirement. Each of the resources waiting here, it will check the requirement, and then it will also check the available resource list. Okay, so it will, based on that information, it will come out with the ready list. Okay, so the resources waiting here is the stimuli lah. Okay, so the available resources list here is the response. Okay, so the resource manager will generate the ready list. This ready list will have the list of stimuli and what type of stimuli, and then what type of the response, and then they will be put in a list, and then all of this list actually ready to be dispatched to the executing process. So this dispatcher will get the info of the available processor list so that it can give or can match which resources and for which processor. After it get that information, then it can dispatch that info to the executing process. Okay, so this is more or less the how the component of the RTOS, how they are working together. But you all can understand more later if you are reading about here about this each of these component later. Okay, so we proceed. Okay, so for the stimuli, just now we have the periodic and aperiodic, right? Okay, so the aperiodic will be based on interrupt level. But for the periodic, it will be based on some time interval. The system will check the stimuli based on some time interval. So the priority level, meaning if your system, real system, have these two stimuli here, okay, so if you all see here, real-time clock and then interrupt handler. If the real-time clock stimuli coming, and then also the interrupt handler also coming to the scheduler. So which process or stimuli that will be need to serve first? So um, the first one that will be the stimulus that will be served first is from the interrupt level. So it has the high priority lah. Okay, so even though in the same time you are actually doing the process that is from the periodic punya stimulus, okay, because you have some time, right? Okay, so that in that time you are serving the response from the periodic stimulus, but suddenly they are interrupt from somewhere, the external event. So the response that is still ongoing for that periodic stimulus will be hold first or pause first, and then it will serve the interrupt, the stimulus from the that interrupt in that interrupting that process. Okay, so the monitoring and control system. Okay, so we are proceeding to one example of system of real-time system, which is monitoring and control system. Okay, so this monitoring and control system are periodically poll a set of sensor which capture informations from the system environment. Okay, so they take action, and then that action will be depending on the sensor reading, and then it will issuing command to the actuator. Okay, so they will give the sensor, and then the system will take action based on the sensor by issuing some actuator. Okay, so let us discuss the same example previously, which is the intruder alarm system. So this intruder alarm system also one of the example of monitoring and control system lah. Okay, so this is when there are various or more than one sensor that will be working together in the intruder alarm system. Okay, so they are like the example previously, they are concurrent system. The concurrent, not concurrent system, concurrent process. So the concurrent process here, they are the movement detector process, Meaning in this process, it will always detecting movement if there are any movement. So there are a sensor to detect movement. Okay, so the door sensor process is the process that is ongoing, and then it will give a sensor or trigger when the door is open or closed. And then also the same with the window sensor process lah. It will detect either the window is closed or open. Okay, so this all process, the concurrent process, will give detector status and sensor status to the building monitor process. Okay, so after that, this building monitor process, if they get the sensor, they will give the room number to the alarm system process. Okay, so after that, the alarm system process will give that room number to the lighting control process. So if they know the room number, then they can light or switch off switch on the light in that room. And then so this system also um, can trigger, other than lightning process, it also can trigger the voice synthesizer process. And then this synthesizer process can give alert message to the communication process. So this communication process, uh, all of this is the response in the alarm system. Okay, so audible alarm process. So another response is maybe there are some voice lah, maybe danger, something like that lah. And then power switch process. Maybe they will make the process or the electrical power, the power inside that room will be interrupted. Okay, so this is the example of intruder control system, intruder alarm system. Okay, so real-time system design process with example. So there are several stages in the design process for real-time embedded software. Okay, so real-time embedded software. Okay, so alarm system with door sensor, window sensor, and motion detector. Okay, so we rest 5 minutes, because it is already 1 hour. So we meet again at 3:35. Okay, guys, 3:35 p.m. Yeah, so we meet again. So um, we proceed to the, this is actually the explanation of the this diagram just now. Okay, um, so this is the example of real-time system design process. So the example here is the intruder alarm system lah. So this intruder alarm system will have alarm system with door sensor, window sensor, and the motion detector. Okay, so you remember the stages previously? There are the stimuli. After that, the stimuli, and then after that, so in this stimuli, we need to identify what are the stimuli and then what are the response. So in case of this intruder alarm system, so the first stage we need to identify the stimuli and response, right? So the example of the stimuli is the intruder alarm. So the response may be uh, computer room number. So it first will generate or detect what are the computer room number, and then after that, the response can be directly called to police, or it also can initiate voice synthesizer, and it also can switch on audible alarm. Audible alarm is alarm that can speak something lah. Okay, or switch on the light. Okay, so that is the example of the stimuli and the response for the alarm system. Okay, so there are another stimuli which is the power failure. If you remember from our this one, Uh, another stimuli is the power failure interrupt. Okay, so the response for the power failure interrupt, we maybe need to, sorry, the response maybe uh, the response maybe switch to backup power. Maybe there are generator lah inside that building. Okay, so after that, the second stages, which is identify the time constraint. Okay, so for the time for the stimuli to how many times or how much time needed for the response to give response. Okay, so we need to identify it. For example, this one lah. So this is the time requirement, the example of how you can allocate time to the stimuli to get the response work. Okay, so for example, for this, the power fail interrupt stimuli, so it will need uh, it will need within 50 millisecond ms millisecond. So this is the example of the timing that you can assign to identify for each of the stimuli and the response. For the door alarm should be the door alarm should be pulled twice per second, meaning it will need to be checked twice per second. In one a second, it will need to be pulled twice. Okay, so after that, Windows alarm, same with the door motion sensor also. Okay, so the motion sensor maybe once per second lah. For the audible alarm, the timing needed uh, within 0.5 seconds, setengah second. Okay, so light switch is within 0.5. Okay, so communication, meaning the time needed for the system to be able to call police. So it should be started within 2 seconds after it detected there's intruder. Okay, so voice synthesizer may be available, it must available within 4 seconds. Okay, before the voice uh, kasi keluar dia punya suara. Okay, so the third stages in the real-time system design just now, if you remember, is to detect the concurrent process. So in this case, we have already know just now that there are three concurrent process, which is the Windows sensor process, door sensor process, and motion sensor process. So after that, the fourth stages is to determine the algorithm lah, to design the algorithm for that stimuli, a set of the stimuli and its response, and then together with the timing plus its algorithm, how it should be carried out using the code, using a code. Okay, so after that, the fifth stage in the RT design is to schedule the system which will ensure that the process are started in time to meet their deadlines. So we need to schedule a set of stimuli and responses, not for individual stimuli lah. Okay, so each of the set of the stimuli and the response together with the timing, we already set the timing and then how it should be done. Okay, so plus what are the concurrent process that will need to be together or processed together, and then plus the scheduling system. The scheduling system is the schedule that will tell which one first, or what time it should start. Okay, so this is the example of how you can schedule the system, scheduling the system for the RT design, RT system. Okay, so for example, every 0.5 second, the action is, there are two action, meaning there are two concurrent process that will need to be happened every 0.5 seconds, which is to pull the door sensor and to pull the window sensor. So for every 1 second, it needs to pull the motion sensor. So if you all see here, it is comply with this lah. Door and windows alarm twice per second. Motion sensor, it must be once per second. So it is with this lah. For every 0.5 second, the door and window will be pulled. Okay, for every 1 second, the motion sensor will be pulled. Okay, so the last stages in RT design process is to integrate the system under the control of real-time OS. So like we have learned previously, the real-time OS is the one or the responsible operating system that manage process and the resources allocation, such as processor and memory. So who is the processor that will need to serve that stimuli or that process, and how many memory allocated for that stimuli and response. Okay, so we proceed to our quiz. Okay, so this is the popular example of questions for this real-time system. So you need to able to think what are the stimuli and response when you are given some type of system. Okay, so for example here, it asks about one stimuli and what are the corresponding responses for a car park system. So it already tell here lah what are the sensor or devices that included in the car park system, which is sensor, barrier, and ticket machine. So what do you guys think? What are the stimuli and what are the responses?
The sensor.
The sensor, yes, that the sensor is the stimuli lah, one of the stimuli lah, right? What sensor?
The weight sensor, car park there.
Wet.
Or how do you check the car is there?
Oh yeah, oh wet. You mean the the weight of the car? If it is already occupied the car, then it will make something happen, right?
Yeah.
Okay, so let's say we have the weight sensor lah. Okay, so what are the response? So let's say there are a car because that place already have weight lah, some weight lah. Okay, so so what are the response that should be triggered? You all have pernah pergi sana apa kan, Imago, and then Imago also have that apa kan. So how do you determine?
The system start calculating the time. You stay there.
Okay, so yes, that one is first. And then there are obvious thing that each of the car park, we know that either it is occupied or not. Green light. Okay, fairer, betul. But sometimes it is not working lah, right? But in logically, when we assume that there are no error in the car park system in Imago, so when we are looking for a parking, okay, so we will see that where are green light, right? So actually the green light will indicate either the car park is occupied or not. Red meaning it is already occupied. Okay, so if they are maybe because I also don't know the car park kan, what is actually the trigger. So like our assumption just now is wet lah. Maybe when there are car there and then maybe there are some wet and then it can trigger the system to change the light to become red. Okay, so people press the button. Okay, so Elvin, you mean this one is the parking ticket kah, Elvin? Because when we go to Imago, we will need to press to get the ticket. Yeah, okay, so actually for just now, what si Kelvin said that the time will be start already. So actually the time will be start once you have get the ticket, right? Am I correct, guys and girls?
Oh, you go.
Yeah,
Right.
yeah. So it is not from the where you get the car park. I mean, yeah, where you get to when you get the car park lah. It is based on it is start from you apa tu pressing the ticket button. Okay, so yeah, that one also will is the trigger lah. Barrier. Okay, so there are a barrier also. When maybe okay, so beside the wet sensor, because we all not really sure what are the sensor, right? So beside the barrier, how you and ticket machine. Okay, so the barrier, how you guys think that it can trigger a response? Okay, so let's say the stimuli is the barrier. So what are the response? Okay, so press button for ticket and then ticket comes out and then barrier goes up after the ticket taken. Yeah. Okay, so the stimuli here is the ticket lah, right? The time the ticket comes out. So that is the stimuli. And then the response is the barrier will goes up. Right? So, right, Kelvin? What is that what you mean? So the trigger for the barrier is the time when the ticket comes out. And then the response will be the barrier will goes up.
Yeah, something like that, like taking the ticket.
Hmm. Okay, so because we are also not really sure the process for the car park system, right? Okay, so what we did now is the assumption. So, um, for example, if you find if you find this kind of questions in the exam letter, you are allowed to search lah, because we all also know, right, not all system that we know how it will the process of that system. So like just now, so this case we don't know actually how the sensor, what are the sensor, either it is based on the weight or based on movement the car, maybe there are some sensor of the movement, right, in the car park. We don't know either it is wet or the movement. So you all may need to do some research, because in the future, maybe in the exam, it will not ask about the car park, but it will ask about another type of system where we didn't even learn previously. So you all will need to search a little bit about that kind of system and imagine what are the stimuli and the response lah. As long as you can understand what is actually the stimuli and what are the response that we can get, the definition of stimuli and the response. Okay, so we finish with chapter real-time design. So we still have about 38 minutes. So I think we can, after this, we can proceed to our another lecture. But I will give you all some time lah. Okay, so we will proceed to chapter software evolution. Okay, so we will proceed. We will use that 30 minutes to cover 30 minutes about software evolution. Okay, so here. Okay, so we will meet again at 5 p.m. 5, sorry, 4 p.m. Okay, guys and girls, 4 p.m. Ah. Okay. Okay, so guys and girls, I'm trying to do the summary for the real-time system just now. So you all can see this Jamboard, right? Okay, so I want you all to participate in this Jamboard. Okay, so the link is in our chat already. So what I will need to do, what I want you all to do is, I cannot do the, this one is eraser, no, oh, this one is eraser. Okay, so as we all know that what we have learned today is real-time system. So real-time system have two types, which is hard real-time system and soft real-time system. Okay, so both of these system, both of this type will require a stimulus, because all of the real-time system will require a stimulus. So there are two types of stimulus that can trigger either the hard real-time system or the soft real-time system. So I want Celine to contribute to one type of the stimulus, and then Nyap Hao Wong to type the second type of the stimulus. Okay? So after that, you all know that we have learned about the 6 stages of the real-time system. So I will need, cannot edit. Yeah. Why ya, this mau juga satu-satu So I will give si Wong dulu, editor, and Slim. Okay. So while we are waiting for them, I will give access. Okay, so Wong and Celine, please put the two types of stimulus. And then we have also learned. Okay, you all can access if I open this. Oh, still okay, okay. So Ivan, Farah, Lim, Jeremiah, berapa orang sudah? Ivan, Farah, Lim, Jeremiah, Elvin, and lastly Zishang Wong Solomon, to give what are the 6 stages. What are the 6 stages of design, of how we can design the real-time system. Okay, so you all can put under these design stages lah. Okay, so the student just now is for those who student, I already make you an editor lah. Ivan, Farah, Lim, Jeremiah, Nyap Hao Wong, Alvin, and Solomon. 6 of you that will need to give the design stages. Yeah. Ngam. Put the number so we know that which is first, which is next. I don't know why this Jambot it don't have the error. Concern if it provided the error. Okay, so we have 1, 2, 3, 4. There's another 2. Algorithm, yes. Stimulus first, timing constraint, concurrent process, algorithm. Yeah, it's better if you all put your name, especially the design stages, because I don't know who already did, who already haven't. Okay lah. So, yes, everyone are already answer lah. Okay, thank you guys. So these are the whatever the summary of what we have learned in real time system design. In real time system. Okay, so just remember so the example. Okay, so I think I will ask somebody lah, two student more to give me the example of hard real time system and then soft real time system. So I will check first who haven't answered. Russell, give me the example of hard real time system, and then Daniel. Daniel, give me the soft real time example. Okay, so Russell and Daniel for the example of hard real time and then soft real time. I will help you all to arrange this lah. Stimulus, Jeremiah. Okay, so already here. Okay, so yeah, Farah, sorry. Russell and Daniel. Please give me the example of hard real-time system, and then Daniel will give me the example of soft real-time system. Yeah, Russell and Elvin. Elvin, sorry, Daniel. Oh, okay. So, can you do access it? I can see that you are joining. Both of you are joining. Okay. So please give me the example for hard real-time system and soft real-time system. What is the EAS? The games, yes. Them? What is them? Them monitoring system. Russell? I don't know what is them. Tempangan? Oh, them is tempangan. Oh, okay, okay. So the sensor will be the level of the water lah, right? Or the stimuli. The stimuli should be the level of the water lah. Okay, so yes, correct lah. Daniel and Russell. Okay, so you all, these are the summary of what we did just now or what we have learned in real-time system. Okay, so we proceed to the software evolution. Okay, software evolution. We have about 17 minutes more to cover this. So remember your presentation video, you will need the due date for it is Friday, this Friday, 17 September, 5 p.m. Okay, so this is the table of content of this chapter lah, software evolution. Okay, so first, the introduction of what is the software evolution, and then after that, during the software evolution, we will learn about software maintenance, and then after that, software re-engineering and reverse engineering. Okay, so introduction. This is the introduction of what is actually the process in software evolution. Okay, so the software evolution process actually vary based on the type of the software and then the development process that you choose in order to develop that type of software and the people involved in the development. Okay, so the software evolution process, some of the software company will make it formal, some of the development company, software house may make it informal. Okay, so the formal, if it is formal, meaning to say that they are exact or they are planned process or activity that need to be done. Okay, so maybe they schedule that every 1 month they will do some checking or whatsoever lah. So they will do maybe meeting. Okay, so it is already scheduled, it is in the plan, so it is considered formal. So sometimes informal, they will only do it informally. For example, they are just they don't need to, they only will do meeting to discuss some important thing when there are some event, outside event that will need them to do the meeting or discuss the process. Okay, so the driver or the trigger of the software evolution process is when there are somebody that propose a proposal to change that system. Okay, so that is the trigger of how software evolution may start. Okay, so these are the process in the software evolution. Okay, first, what after there are a trigger, where there are the proposal of changes from maybe from the external entity. Either it is the client, maybe they need a new feature, or maybe there are some bugs in the system, then they will need to fix it. And then so any trigger from the outside that will need the software company to amend the software will can trigger a software change proposal. So based on that proposal, the software team will need to do the change analysis. So they will need to analyze either the changes requested will be can be proceed or not. Okay, so sometimes because of some of the situations, like maybe the changes may need a very state of the art technology, and then maybe the cost for that changes will be a lot. So the software development company will need to decide lah, either to proceed or not. So if they decided to proceed, then they will proceed to the release planning, meaning they will need to they will be proceed to system implementation. Wait, change analysis, release planning, system implementation, and then system release. Okay, so ngam lah. Okay, so they will need to analyze either to proceed or not. So if it is can be proceed, then they go to the release planning. So they will need to plan in what version the change will software version. Okay, the change will need to take place. And then after that, they will do the implementation. They will code the amendment. After that, they will release the system. Okay, so the release planning here, actually when a software company give a version number to their software, actually it will be depending. If I am not mistaken, I don't know if you all will learn about that in deep lah, but maybe in the real world later, you all will learn that actually the version number of a software, it is not actually suka-suka hati kena bagi. Okay, so if you see that there are version of the software is 10.1.01, and then after that, the next release, it is 10.1.02, and then the third release tiba-tiba it is terus directly go to the 10.3. It is not 10.1, but it is directly to 10. Maybe it is directly to 10.2, even though the previous version only 10.1.2. 10.1.2. Okay, so and then we expect that the next version will be 10.1.3, right? But tiba-tiba the third release, it is already 10.2 already. It didn't continue the 10.1. So why is that happening? Is because it is depending on uh, the changes they make to the system. It is just a minor changes. So the version also only berubah sedikit. For example, if it is just minor, so it will only change from 10.1.1 to 10.1.2. So that means it is the changes, it's only small, minor changes. But if it is already directly go to the from 10.1 to 10.2, okay, so that means the changes that they made to the system is major lah, because the number or so change drastically. Besar lah dia punya jarak. The gap will be huge. Okay, so the version number, so that planning should be come here, should be done here. Okay, so this is the process of software evolution process when the company receive a system change proposal. Okay, so remember this four process. Okay, so these are the details process of what is happening. First, we receive the change request from anybody, even though the software company itself may request a change. Maybe when they are exploring the system, they see that actually some process can be simplified. Okay, so because previously maybe they didn't aware about that, and then after that, after the system is in use, so they think that some of the process, because of maybe some of the algorithm is too complicated and it require a lot of processing time, so they will think that there are better way of coding it. So without affecting the behavior of the system or the output of the system, they make the code better or simple, and then thus the processing time also become shorter. So um, what I meant is the change request maybe come from the software company itself. Okay, so it doesn't necessarily from their client. Okay, so after that, they will do impact analysis, like I said just now lah, do release testing, and then implement the changes, and then after that, they will do the system release. So this process will be can be repeating as long as there are a change request from the outside. Okay, so this release planning, um, okay, so like I said just now, sometimes if it is just a fault repair, so maybe it is just a minor amendment. So maybe the version release will be just a minor. Like I said just now, maybe from 10.1.1, it come to 10.1.2, meaning the minor. So, but for example, the amendment is a major amendment because we need to adapt for the platform. Maybe if previously our system is just a website that can be accessed through browser in our desktop, but the client demand us to for them to have it also can be it also from a browser but a mobile browser. So there are some changes because uh, to code based on the desktop and browser from the mobile, it will need like a lot of changes in the code because mobile and desktop will have different size. So all of the code will need to comply with the mobile size. Okay, so that kind of amendment may require major changes. So yeah, so the example here, the platform adaptations lah. Okay, or system enhancements. So system enhancements, it will be depends. Either it is just a small feature, or maybe it's the major. Maybe there are one big module will be added. So yeah, it will need to be planned during the release before the implementation should be done. Okay, so software maintenance. We proceed to the software maintenance. So software maintenance is also one of the process in the software evolutions lah. Okay, so actually, yeah, so in this subtopic, we will learn about the types of software maintenance and the factor that will affect the maintenance cost. So I'm sure the SF students is maybe still remember about this. So, the process of the software maintenance is, if you all remember the SDLC, it will be the last stage of SDLC. Okay, so it is the process of changing the system after it is delivered to the client side. Okay, so after we have done all of the software development stages up until testing, and then The last part is the software maintenance, meaning we already give it to the client, and then when the client need to change something, even though we have even when the system is already in their site, so that process will be under system software maintenance lah. And so the trigger, the reason for the system to be changed during, even though it is already in client side, is because maybe because of there are some error or bugs that didn't discovered previously in the software testing. So the when it is used by the real user and then they use it for a long time, then they discover that error. Okay, so after that, maybe because of the installation of new hardware, like my example previously, if previously your client company only need the system to be accessed through desktop browser or laptop browser, but maybe they demand the system to be accessed to through the browser, but it must be compatible with the mobile browser. So we need to maybe change because we need to adapt to that new hardware, and then because of the customer needs, so maybe they will need when they after they are using our system, they think that it might be good or it might be easier if they have another module that also can help them to process their daily operations lah. Okay, so we will learn about the types of software maintenance. So there are corrective maintenance and then adaptive maintenance, like when we need to adapt to the hardware just now, like from the desktop browser to the mobile browser, and then maybe our client will use new OS. So because of the new OS is not compatible with our current system, so we need to adapt with the new OS. Okay, so that is the adaptive maintenance. Corrective maintenance is just now is any changes to the system because of the bugs or error lah. Okay, so the perfective maintenance is when new functionality or non-functional requirements are needed because we want to make the system perfect. Okay, for example, previously the interface our system is just so, and then when you see another company which is actually running the same, or when your client lah see another company which is actually running the same type of business with them, but their website is very cantik, very chunky, then they will request to you, or maybe they will get back to you, I want our system or interface of our website better than this company A. Okay, so that is there are no adaptation or there are new hardware, there are no new hardware, there are no bugs, but they want their system to be perfect. So that is what we call as perfective maintenance. Okay, so I think we can stop here. So we stop at the factor that will affect the maintenance cost. Okay, so in the software evolution, we have learned about the process of changing the process of processing a change proposal from your client, and then the three types of software maintenance, which is the corrective, the adaptive, and then the perfective maintenance. Okay, so this Thursday, so we will discuss the tutorial for chapter real time design, and then after that for another hour we will continue this chapter. Okay, guys? Okay. And then your video will be the due date is 17 September 5 p.m. this Friday. So may I get the raised hand if you all understand what we are going, what we will need to do. Raise hand for all, if you all uh, aware. Okay, wait, let me check. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wait, Wong. Can wear 1, 2, 3, 6, 12, 18, 14. Oh, there are someone missing here. I only see 14. There's somebody missing. Wait, let me check if I can. Lim, Jingming, Lim. See Lim. Lim, right? Lim absent, right, today? Okay, so your group member, please tell Lima about our change of uh, we didn't do the presentation this Thursday about our plan for this Thursday. Okay, guys, do you have any questions? Okay, no questions. Okay, so yeah. Okay, so we can dismiss our class lah. Okay, thank you very much for your attentions and for your commitment. Okay, bye all.